Okay, start with a set out. We're going to do a B set, which is for the borders, and we're going to go 1 to 100, and these 6 of those. Insert. Hold on, I'm going to take it. Oh, yes, it's already in Imperial. Okay, first we'll lay out the roof. Now,
55 foot run by 33 foot. 35 by 55.
Okay, 55 feet by 35 feet, and there's our little outline for the actual outside roof. Now we're going to lay out the wall. Start from the same location, but it's a little bit smaller. So it's 53
feet by 31 feet.
By 31 feet. Let me just put in a comma. 31 feet. Okay, now I'm going to move this up 1 foot, and we're going to move it across 1 foot. Now I'm going to use a TR command to convert the outside line to a roof line, and I'm going to use the TS command to convert the inside line to a support. Then I use CRL to create the shape of the roof. Then I go straight in and do a truss settings. Make sure it's designing by the American code. Sheet metal roof, 56 meters per meter per second wind speed. Roof pitch is 4 on 12. Or 12. Yeah, 4 on 12. And the height of the roof location is going to be 25 feet. The hip method we're going to use is truss style. Once again, we're going to go on 2 foot on center. The first truss is going to come in roughly about 4 feet. And we're all good to go. There's the loadings for the roof live and roof dead. Okay. And from there we use the TDT command to lay out the, hold on, before we do that, I'm going to recreate the roof and the walls so I know my location when I start laying out my walls. So I'm going to send that up there. Okay, now I use TDT to lay out the actual trusses. No, we're going to go to the outside. That's right. Yeah, go hip to hip. Now, if we have a look, we have our roof laid out. Go back to plan layout, switch off the 3D, label, then we do a truss takeoff, send it to truss engineering, which is doing now. Now at the moment it's doing a very light gauge. We might switch it out to a much heavier gauge. Just wait till they finish. We decide that we're going to switch to a much heavier gauge system. This is the heavier gauge system. Save that. TDT. Check, make sure it is all good to go. Back, hip to hip. Label. Do the takeoff again. And this time we will use a bigger border. This time we will build with a heavier gauge, and there we go. Most of the trusses you can see should work okay. with a slight modification. Just wait for it to finish. Now, as you can see, every single truss is being tested, and you can see whether it pass or fail. Now, we won't go through the exercise of fixing every single truss, but this truss in particular, we can close up the spacings on the webs, build it. As you can see, it clearly passed at 85%, so we can make it work. We can apply the similar sort of rules to all the other trusses. Inherit, so 1200, build, and again that pass. Now we can be a little bit trickier for these ones. We can quickly add a web here and add a web here. We're just demonstrating how easy it is to modify the truss here. Oh, we have to remove the overlay. Oh, before we can do that, I forgot. I have to inherit that and put it maybe something much cool. Just wait. I have to go back to the original truss. One second. Okay. Building the original truss. Okay. Okay. Now, as you can see, these particular trusses don't perform very well when it's on a lower depth, because you can't box them, and you really can only have one choice of going up. So you can see one of the inconvenience of having these sort of trusses, where you can make it work on a deeper channel, and we can see this on this one here. If we do a truss analysis, you can see the wind will apply, and for this one we can have a look where it's actually failing. 127% top chord, and it's going to be deflection, way past deflection 43. And have a line diagram, it's around this area. So we've got to find a way to somehow stiffen this up. Okay, so I'm going to try and get rid of these two. Introduce extra webs to try and compensate. Now it's getting close but it's still not passing 106%. We need to get it down to 90%. We could add another word here, or we could try 119, see what's failing. Or TR.
Let's put that panel point up.
Yes, we will have to. So you can see we can quite easily why are you still failing? It's that one there. So what I might try and do, no, go reverse on it. Let's see. Close. Does not like us, does it? 12%. It's deflecting too much upwards. Okay. Wow. Just removing the label from one to the next. It's moving upwards. I have to somehow stop this from moving it. Give it a try. An extra piece in there. That's right, we cannot box these ones. So how we can get around this one? Just erase where. Just will not pass this one. Well, you can see what
18 gauge yet?
Well, not quite 18 gauge yet, but that's about. Let's move on for now, because this one here we can make it pass. So, oh, this one. Oh, the height is on enough. We didn't put it back far enough. We didn't go 6 foot. We went 4 foot. Let's move on to the walls for a second. We'll come back onto this one. Yeah. Okay. for the walls, I'm going to copy this one small. Walls, we're going to go SWA, send that SW, okay. So, the outer walls, where's it stop? Outer wall stops at, oh, that one. No, it can't be 35.
45 foot 8 inches.
Okay. 45 feet, 8 inches. That's right. Okay, and then we'll have that hexagonal bit that come out. Let's do that first. So let's start with setting up the walls. We're going to use a 3.5 inch wall. Maximum length, all that is good. Location 0 tolerance. This is all good. Save. We're going to go around here for now, here. And how far is that?
5 foot from the face of that wall is where our pop-out exists.
Okay, so 5 feet. Offset 5 foot. There.
Okay.
How far is that come across?
From that wall, it's going to come across 4 foot 6 inches.
4 foot 6 inches. Yeah. So basically a 5 foot by 5 foot, really.
The face of the octagon is 6 foot. So we're on 4 foot 6 from the corner over to our first pitch, right?
Oh no, I know what to do. Hang on, I'll set that 5 feet. 5 feet. So I know what. That can't be 5 foot. It's way too small.
3, 4 foot.
No, you got to go all the way across.
For the whole thing?
Yes.
Yeah. Okay, that is 14 foot 11 inches.
Okay, that's better. 14 feet
11 inches.
11 inch. There, that's better. Okay, so if I went front edge, side edge, side edge, front edge, side edge, no, it's not long enough. Okay. Now bear in mind the measurement might be a little bit different to what you're doing, but for demonstration, it's good enough. Okay, so from there, I'm going to go from here to there, plus to here, and I'm going to go another little wall there, another one there, another one there. Okay, what I need to do is cut that one, because we can't have it overlap. Can't have that overlap. Okay, let's give me the wall
From the back,
yes,
you're going to come in 12 foot on the left side.
12 feet.
And
Hang on. I need to make sure that's 12 feet. No, I need to move it. That's 11 feet, 8.5 inch. So I need to move it another 3.5.
Yep.
3.5 inch. Oh, where's the wrong way? Oh, hang on, hold on. That's right now.
Okay, now your next wall is 10 foot over from that one.
10 foot.
Mm-hmm.
Yep.
Okay, your next wall is going to be 5 foot 9 inches over from that.
How many?
5 foot 9 inches. Okay. Now, from the bottom exterior wall up to your left-hand corridor wall, it's going to be 12 foot 7.
This one?
Mm-hmm.
This way?
Yep.
12 foot
7 inches.
7.
3 foot 2 over.
Hold on. And 3 foot over?
3 foot 2 inch over.
3 feet. Okay, move that a bit more. Okay.
And now you need to trim all these walls away. On this side of the corridor, I'm going to lay in walls on
Hold on.
all these walls. So you get trimmed
No,
away.
I need to trim that one first. That one on that side. That's right. That forms the master bedroom.
Yep.
Now that wall does go straight through.
Yeah. But this wall doesn't exist.
You mean this one?
Right.
Okay, this side. Okay, so
That's correct.
now I need to go.
Trim it up. Yeah. Trim.
Now I can trim it. Okay.
Okay, but now that wall is those walls don't exist there. They've got to be moved. The only one that stays there is that one.
Which one? This one?
Yeah. That wall. Well, that wall's not even in line. It's a different offset. So you want to just move them distance.
Yep.
See, this wall is 70 by 10, 6 off that wall.
10.6 off this one?
There's no, yeah.
Okay.
Okay, now offset that line again. Yep. By 5 foot 8 inches.
Okay.
And 11 foot 6 inches. Offset that line.
11 foot.
6 inches. Place a wall there on this one. Okay, now get rid of those two all the way protruding into the living room. Yep.
Alright.
That's it. No, we got
Closets.
do we want to worry about putting closets in this wall?
Oh, we don't have to. I'll put in a few doors in, but
Yeah.
that's not quite right either, because you got this weird WC or walk-in closet,
Right.
and then it's got another wall. It's going to take a while to
Well,
put all
that's a
that in.
bathroom. It's your shower wall.
but you've got this thing that has to go around.
Right.
So it goes up 45 and across. So we're going to put that one in, and that one's got some sort of linen in there as well.
Right.
We don't need to worry about the linen for now. Well, although I'll just draw the linen. How far does the linen come out? Doesn't tell you. Okay, so hold on. It's going to come out this far whether you like it or not. Doug, that's your linen. No, here, I got the linen under control. So what else we got? We got some doors and windows we got to put in. So let's do the windows and doors first, Doug.
Okay.
And then out here we still got the columns and beams to put in. So we'll get on with these first, Doug. Okay, there's a beam sits out here, and then last but not least, we also have a beam sitting out here, which means we're going to have to trim that one back a little further. We'll fix that more detail in a minute. Then we've got columns that run along the front there. We're going to need at least 3 of those.
3 columns.
We'll use the ones that we already created. This one. Maximum spacing, let's do... What's the width of this building?
35 feet, 36 feet. So I'd use maximum space.
10 feet.
Okay.
Oh, we haven't done
No,
that height.
10 won't work.
Divide that by
36 foot by you need 12. Right, good.
No, actually, we won't do that yet. We're going to put in doors, and then we go. Okay. Let me just put in some regular doors. That's too big. What's a regular door?
3 foot, 32 inches.
So 2 foot what?
2 foot 8.
That means that's always too small.
Oh, it's 3 foot 2. About measure 3 2.
And this one do. Three two. So if I did
do a
2 foot
2 foot 6, 30 inch.
that's better.
Okay.
I'm going to do all the rest of the door pretty much the same.
Yeah.
Just to make it so. I'm going to do another one on the side here. Come off. How far do you want to come off?
3 inches.
A bit more than 3 inches.
For casings.
It's a bit hard to get 2 studs in there. Now what else do we need door? We need door over here, don't we? 6. 6. That'll do it. And is there any door into the... Where's the main door?
Right over here on this exterior wall.
On this one? Mm-hmm. So how far is it?
There, and there's the double door here.
There's a double door? Mm-hmm. We'll just stick that in the middle between the things.
Okay.
So
it's a
no, I got it. Why do you insert mine?
Hmm.
I want to insert mine. And you got a single door.
Single door there.
Oh, we've got to put a window in halfway between the window and the other wall. Okay, so we need to put some windows in. What's a height for a window? No, the actual window height. No, down to here.
The handrail.
No, but that's the bottom
Oh,
window
the
there.
actual height of the window. Okay.
So 5 foot?
6. Yep.
And what about the width? One half?
Yep.
Okay, so height 5 feet. Width 1.5 feet. 6 inch. We're going to put it everywhere. Don't worry. Now, where's another window? Let's just mimic them.
Got one more in the living room. You've got.
Yep, no. I'll put them in. It's
Yeah.
just like. I know that's not the exact design, but
Right.
the procedure is pretty much the same. Well, is that at the back or is it's on the side?
Yeah.
Okay, I'll just put it in here. And then I might put another one in here. And then I'll put another one. There. That's your door. Okay, that's good enough. Okay, then we have to determine the height for these load bearing walls. How many feet high?
Ten foot. 10 foot.
10 foot?
Yep.
Now, if that's 10 foot, that means our floor, let's see,
Means our floor is at
15 feet.
feet.
Okay. Base level is at 15 feet. Okay, so our internal walls is at 9 feet, so an inch down.
9 to 11 inches.
Okay, now our beams are we'll just use a purlin for a beam.
Okay.
Height, that's fine. Remember the height of the beam is 7 and 7/8. Okay, because we need to subtract the beta. Okay, so top of the beam is at 25 feet. Code it, and that's it. Enough for us. Okay, we're going to fillet that one onto that one, fillet that one onto that one, and then we're going to go and put in some columns. Use existing. Fine. Now the maximum spacing is at 12 feet. Now the height would be
25 foot less, 7 7/8, I think we said. So
yeah.
Be 24 foot 4.
Yeah, but it's not, because it's actually, how high is our wall? 10 feet.
10 feet.
It's 10 feet, subtract that.
Okay, so 9 foot 4 inches.
9 foot 4 inches, and it's this one, the level is going to start at 15 feet. That's why. Save. Yes, yes. Oh, we're in level 4. Doesn't make much difference. Okay, let's have a look at this now. So what we need to do is put a reference point on the walls, a reference point on the truss, and then we get to have a look. So I know the house is floating at the moment, but generally I think we're looking pretty good. So all we need to do now is lay in the floor. Okay, so for the floor is going to go how? So
Floor is going to be.
So this is the footprint on the outside. That's where the walls are sitting. So are you saying that it goes beyond a little bit? So how much beyond? Because this audio, don't forget, this audio incorporates the veranda out. So this part's already incorporated. Now don't forget, we're only doing this so we can lay in some columns and hold up the floor.
Okay, yeah, the floor needs to be 34 foot 6 inches by 53 feet.
So if you have a look, this wall print is already 31, and the length, I think the length is fine, 53 feet. We already got that. It's this one
It's
here.
actually 55 feet. Yeah, 53 for the floor.
Yeah, so we need to go out. No, it's the width that we need to go out.
Right, 34 foot 6 inches.
34 feet, 6 inches. So the floor needs to go out there to cover. Okay, so in that case, what I'm going to do is how many rows of columns have they asked for in concrete? Go back to the floor. No, not those columns, the actual floor column. Go back to the floor layout, underfloor layout. That, yes. 3 rows.
3 rows. And 1, 2, 3, 4 piers deep.
Okay, so that's fine. So what we're going to do is we're going to mimic.
It's actually 5 piers deep at that pump out there.
No, we add those two. Don't worry.
Oh, those two are already there.
No, we're going to go across this way first.
Okay.
Okay, so 3 of those. So we're going to go from here up to there. That's fine. So what are we saying? It's 34 feet or something like that?
Mm-hmm.
So 34 feet 6 inches, divide that by 1, 2, 3. Divide that by 3. 11 feet would do it.
Yeah.
11 feet would do it. So what we're going to do is we're going to cheat a little bit, and we're going to create a column that doesn't really make any sense. We call it P1, part number 1. It's going to be a square profile. Now, what width are we going to make it?
These,
just a rough.
Yeah, these are 12 by 12.
12 by 1 foot by 1 foot.
1 foot.
1 foot. And the depth is 1 foot. Okay? Doesn't matter. 24. What do you mean? Incomplete. Oh, it wants it in metric. Don't worry. Hang on. P1 part 1 square width. Say 1 foot. 12 inches. So I know what to make it. I got it. Okay. Maximum spacing is how much?
We said 11 foot.
And overall height. Now, let me just say this. A foot deep. Okay, so this is going to be a little bit tricky, but we're going to go about foot deep on the joist. We're going to use some solid joist. Okay, so 15 feet minus 1 foot.
14.
14.
15 foot minus 1 foot.
14 feet.
Yeah.
So 14 feet. Overall height is 14 foot. Maximum spacing is 11 feet. Save. And we're going to go from here up to there on this side. Yes. Yes. Ooh, that's way too big. I'll tell you what we're going to insert. I'll tell you what we're going to insert.
$304 centimeters or millimeters.
No. I made these way too big. That's why. 25 feet. It's got the wrong. It's got the wrong thing on it. See? Okay. Now that's better. Maximum spacing 11 foot. Height 14 feet. Save that. It's making it so big. It's out of scale. and scale. See, look, it's not accepting the. Oh, we'll use these. All right. We'll use these just for demonstration. 11 feet, 14 feet. Save from there to there. Yeah. Too many. Got to be 1, 2, 3, 4. That'll do.
I'll just let it be for this purpose of what we're doing.
Okay. How many we need? 5 rows?
5.
The last row is not like that, is it?
No, the last row you only get 2 with it. It's out there at the okay, there, and then erase the top. 3.
No, that can't be correct. That's better. Actually, it's all more out too. Because we're not spacing the same as what they're spacing.
Right.
So do the platform. But our platform still needs to go all the way out, even though sync.
Yeah.
So that means these are still. Okay, so that's fine. What we're going to do is we're going to do. Okay. 1. I'm laying out the floor now. I'm just creating the perimeter of the floor sections, yes.
The rim track.
Yep. So when you look at it, we're going to go like this. Get rid of that. Get rid of that. Get rid of that. Why is that out so much further? That's better. Okay. So what we're going to do is we're going to set, so you can select different purlins from the system. You have different heights. At the moment it's still metric, but we will get all converted to imperial. Joist spacing, what are we going to do? 2 foot on center?
2 foot on center.
2 feet. Internal burr doesn't matter, we're not going to use them. The height is going to be 15 feet because that's where the floor
levels are.
The loadings are fine because it's all PSF. Save that. Use the command called JD to lay in the floor. Select the square we're using. Select the starting point and show it which direction you want to run the joist. Same again. It's quite easy because I broke it into 4 separate panels that all match up. Now, if you have a look, if I reference this to the rest of the building, I think you'll find that we have a complete little building. Now we haven't got any of the floor joists, but our little building is pretty much complete. So, last but not least, let's go back to here, turn the 3D off, turn this on, lays out all the studs, the track, lays out all the windows, headers. We can have a look at here. Now, last job we got is show you win load calculations. You see what's required here. Now we can go in and place some bracing within the walls. So this is what I would do. Insert some bracing into these. Let's put some here. Put some bracing into these walls so we know what we're doing. Let's put some here also, and then back. And as you can see, we get some bracing into our walls to stop the racking. Now from this point, there's a few more things we can do. We can label all the floor joists and ask the software to give us a report. Sorry, on the quantities that we require plus the weight. Again, it's in metric at the moment, but we can get that taken care of. We can do some reports on the walls. This is the design summary, how many of each type of walls you've got. We can do this, will show you what wind speed, what roofing material, all that we're going to calculate with. We can also report on the number opening that is existing on this building.
Can we do a shear wall report?
Yes, we can. We can do a this is shear wall report, the required wind, the racking resistance, all reported. We can also do a wind uplift report to show us what hold down is required for each of the trusses. We will also do a quick demo on how to dimension our walls. Okay, and we can also get the software. We haven't broke up the walls, that's a problem. Because the stack's not going to be very good with long walls. Right. So what we should do is go in and cut this one, break this one. That's good.
So now we'll do a wall panel shipping report?
Yes, we will. We will. Relabel them. PT. This is the shipping. Oh, not very good stack. We need to cut some more walls up. L1 is still too long. Okay. This one is still a little long. Yeah, this one's still a little bit long. That's better. One stack plus a couple, so we can shift some of these out to this stack. Probably shift these. Although I don't know if I want to shift them like that. Yeah, we could.
Yeah. Now what we need to do is we need to go back and redo the shear wall report for the hold down, so now that we have broken panels again.
Oh, there's the wrong one. That one could go there, you know. Okay, so if we go back and do a new report, what this will give us is a new report. Okay, because the wall's been broken up.
And it'll also change your anchor bolt diagrams.
Right. But last but not least, we'll do some reports for the trusses. Same wind design, dead load, live load, how many each is required. Ooh, move that inside. Oh. As you can see, we've got everything from dead load to live load to dead load on bottom chord, live load on the bottom chord, different pitches, and the number of trusses required. We can also
put a miscellaneous metal report for hat channel. And
no, we'll just do a measurement for this first. Okay, and that one there. We can also do a quick area calculation. So it won't be in metric. Period. Yeah, we'll have to convert it into imperial before we can use this one. But what was the other report you wanted? Accessories. That's right. I'll put it on the right hand side. There we go. And you've got your little hat channels, you've got your jack rafters, you've got your different clips that to hold down the trusses with, and that is pretty much our project. We can literally send these to the machine and have it produced.